Welcome to One Chemistry. Always try to do your best. Now let us see about 100 concepts in organic chemistry. We are seeing it as episode. This is the episode number 32. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the first question here. The starting metal is naphthalene attached with ethyl group. There in the first position, you are in the NBS2 equivalent and light and CCl4. They ask you to find the product. Whether products of bromination happen in the same carbon or different carbon or happen in the benzene or happen in the benzene different position. So 4 different products. So from the reactant and 4 different bromine products, you might realize the question is really about regioselective substitution of bromide. The answer is B. Let us see how. The starting metal you are using N-bromosuccinamide. It is a radical initiator. So it can initiate radical from benzene ring and the methylene one. But methylene one is easy because of sp3 hybridization, less electronegative. Benzene one difficult to break it up, so you have radical formation. Then it can also supply bromine radical, bromine attachment will be there. Here you are using 2 equivalent, so next equivalent you are adding NBS where the radical will form. The radical formed at different position than the available bromine. Because bromine is the electron withdrawing group, it will not stabilize the radicals. So the radical form other side. Again you have bromine supply, you have dibromide formation in the 1-2 position. So the answer is clearly B there. Here the concepts you have to learn here is free radical substitution not possible in the benzene ring because of electron richness. Second thing is radical is like cation, it will be destabilized by electron withdrawing group. Then let us see the next question. The starting metal is bromine, which is in the bridged form, which has either side 3 carbons. So it's basically the bicyclic system. Here they are asking IUPAC name of it. The name is 9-boro-bicyclononane or 1-boro-bicyclononane or 9-boro-bicyclooctane or 1-boro-bicyclooctane. So basically it's octane or nonane, or you can say the question is really about numbering versus boron bridges. Here in the 4 answers you have 2 differences. One is octane and nonane and the numbering 1 and 9. So from the structure and possible 4 values you might realize the question is really about numbering versus boron bridge. The answer is A. Let us see how. The 9-boro-bicyclo-331 nonane is the answer because in the bicyclic system you have to count boron also as a carbon, so it's a nonane system. So 8 carbon atom, 1 boron, so ring size is 9, so it's a nonane. Here numbering you have to start from next to bridge. So 1, 2, 3, 4, 5. Both sides is symmetrical, you can start from either way. So boron in the 9th position and it is a nonane. Either side you have 3, 3. So 3 carbon on either side, 1 is on the bridge. So the name is 9-boro-bicyclo-331 nonane. Here the concepts you have to learn here is in a ring, heteroatom will be considered as a carbon. Second, the numbering start next from the bridges. Then the next question, the starting metal is quinoline, you are using lithium and liquid ammonia. They ask you to find the product. The products are mostly a reduced one. Here double bonds are reduced. The 4 possible structures are given. Double bond reduced from benzene side, double bond reduced from nitrogen side, double bond reduced from benzene side with 2 reduction and nitrogen side with 2 reductions. So there are the 4 possibilities. So from the question and possible 4 answers you might realize the question is really about regioselective reduction here. The answer is B. Let us see how. Here the reaction is a Birch reduction. You are using lithium and liquid ammonia. Basically in the Birch reduction the radical anion stability decide the product here. So the reduction may happen at anywhere, only stabilized product is achieved as a major one. The stabilized one achieved by the reduction happened at the 4th position. First let us see step by step. First, electron donation occurred from the liquid ammonia. Electron is donated, radical anion is formed. This anion is stabilized by nitrogen. Nitrogen is the electron withdrawing group, it stabilizes the anion. Then again the second electron, you have anion formation. Then you have the H plus addition, you have final product B there. Here the concepts you have to learn here is Bitch reduction. Bitch reduction always intermediate is radical anion. The radical anion stability dictates the product here. Then let us see the next question. The starting metal is benzophenone and you have chloroethyl acetate. You are using sodium methoxide. They ask you to find the product. The products can be 4-member ring or an open chain with chlorine and ethoxide in one position, or a epoxide ring or chlorine and OH in the opposite direction. So there are the 4 possibilities. So from the reaction and possible 4 answers, you might realize the question is really about whether a linear chain is there or not, or cyclization occur or not. If it occur, what is the ring size? The answer is C. Let us see how. Here, if you look at the mechanism, it will be easy to understand. First step, you are using sodium methoxide. It abstracts the acidic proton. The proton is acidic because both sides electron withdrawing group. So the anion is formed there. Then the anion attack the carbonyl. You have new CC bond and the anion is there. The anion has to be quenched. Chlorine is the good leaving group. So what really happens is O- attacks the CCl carbon. You have 3-member epoxide formation. If you read it nicely, you have the answer C. So the concepts you have to learn here is you have to identify the reaction center in the reaction. Most of the time the acidic proton is very reactive. It can generate the nucleophile very easily. Second thing is charge quenching. You have to always find the ways to quench the charges. Mostly it occurs with the good leaving group. Here anion is there, it attacks the Cl, you have 3-member ring formation. Then let us see the next question. They are asking pKa value of 3 compound. They given pH NH3+, isopropyl and NH2+, and pH NH2+. Basically all are ammonium anion with different substitution, phenyl and isopropyl and diphenyl. So from the question of pKa and possible 3 structure, you might realize the question is really about substitution versus acidity. The answer is B. Let us see how. Here you are looking at the acidity, but it's in the wrong way. Here you have to write the conjugate base because it is the amine there. So analyzing the basicity easier than acidity. So we write as a base there. If you look at it, you will easily understand which one is strong base. Base is the one which donates the electron. Here isopropyl is the electron donating group. It donates the electron very much. So the nitrogen attached with 2 isopropyl is the strong base. Second thing, phenyl. Phenyl is a destabilizing factor. So what really happens is it will withdraw the electron from the system because it is a sp2 hybridized one. So more phenyl, weaker the base will be. So conjugate acid will be reverse of that one, and you have to reverse it for pKa. So the acidity trend is similar like conjugate base. So you have the value of pKa, pH2NH2 plus is the least one, pHNH3 plus and isopropyl NH2 plus. So the answer is clearly B there. Here the concepts you have to learn here is the electron donating group increase the basicity. The sp2 carbon, which is phenyl carbon, decrease the basicity because of its electron withdrawing tendency. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.